Right. So the question is, we've been given 3 points. There's a point A which has the coordinates k, comma 3. A second point B which has the coordinates 6, comma minus 2, and a third point C which has got the coordinates minus 3, comma 4. And we are supposed to find the value of k for which the 3 points are collinear, which is just another way of saying that we want the 3 points to lie on the same line. And this is going to happen for some value of k, not for all values of k, but it will happen for some value of k, for A to be on the same line as B and C. Now the thing to realize is that if this, let's suppose, is the x axis and the y axis, so this is our coordinate system, and if in this coordinate system there is a line, this line over here, it should be straighter. So let me just draw it the straightest that I can. So it's this line over here. This line has a single slope. It's a single value, and it doesn't matter which 2 points on the line you pick to calculate that slope. You need 2 points to calculate the slope of a line, and it doesn't matter what those 2 points are. So they could be, you could pick this point over here and this point over here, or you could pick 2 points over here. You will get the same slope for the line. You could even pick a point which is far down over here and another point far up over here. As long as they're on the same line, you will get the same value for the slope of the line, which means that if I were to calculate the slope of the line, m is the slope of the line, using points A and B, then I will get the same value as if I were to calculate the slope of the line using points B and C. It's as simple as that. Now, the expression for the slope of a line using points A and B is the y-coordinate of A minus the y-coordinate of B divided by the x-coordinate of A minus the x-coordinate of B. This is from definition. And the slope of the line using points B and C would be the y-coordinate of B minus the y-coordinate of C divided by the x-coordinate of B minus x-coordinate of C. And over here, in these two expressions over here, the x-coordinate of A is the k that we are looking for. Everything else is known to us. We have been given values for all of the other x and y coordinates. So now it's a simple question of just plugging in the values and then just solving for k. So let's do that over here. So the y-coordinate of A is 3 and the y-coordinate of B is minus 2. So that's 3 minus minus 2 divided by the x-coordinate of A, which is k. This is the k we are looking for, minus the x-coordinate of B, which is 6. So k minus 6. This has to be equal to the y-coordinate of B, which is, oh, I always do this. It's actually minus 2 minus the y-coordinate of C, minus 4, divided by the x-coordinate of B, which is 6, minus the x-coordinate of C, which is minus 3. This gives us, which implies that 3 minus minus 2 is 5. So 5 divided by k minus 6 is equal to minus 2 minus 4 is minus 6 divided by 6 minus minus 3 is 6 plus 3, which is 9. So this is kind of easy to solve. So we'll just cross multiply. And what that will give us is minus 6 times k minus 6 is equal to 9 times 5, which is 45. So let me see if I can just move this down. Oh no, that moves it up. There's a way to move this down. Yeah, this is the way to move it down. And what that means is that minus 6k and minus 6 times minus 6 is plus 36. So minus 6k plus 36 is equal to 45. Which implies that minus 6k is equal to 45 minus 36, which is equal to 9, or k is equal to 9 divided by minus 6, which if you just divide the numerator and denominator by 3 will just give you minus 3 by 2. So if A, so k was the x-coordinate of A, right? So if A is, let me see if I can move this back up again. So if A is equal to minus 3 comma 2 by 3, then it lies on the same line as points B and C. So that was the question, and that's how you do it.